At 1314 section IC1 spring 2022 Tyler Junior College, homework 7.4, the rational zero theorem and the fundamental theorem of algebra, video 6, building a polynomial function from its zeros. Let's take 2 of this video because I got toward the end and realized I was not recording. And I had a lot of stuff written, so this one's just going to be a big reveal on each page. All right, so let's get right to it. We're going to reverse engineer the process. Instead of giving a function and finding its zeros, we're going to start with the zeros and end with the function. For example, write a polynomial function f of x that satisfies the following conditions. Number 1, we have a polynomial of the lowest degree. That basically means we don't want any more factors than necessary. Number 2, we have a zero of -2, but with multiplicity 3. Thirdly, we have a 0 of 3, but with a multiplicity of 1. And finally, when we put in 0, we want to get out 120. In physics and engineering, this last thing is what's known as an initial condition. Initially, our polynomial has to satisfy these values. So how are we going to do this? Well, we've kind of done this before, but in the other direction, where we start with a factor and turn it into a 0. Now we're just turning a 0 back into the factor. And the factor theorem helps us out with that. From the factor theorem, we know that if x equals c is a 0 of the function, then x minus c is a factor. So every time we have x equals a number as a 0, we can just subtract it from x, and that will become a factor. So each 0 becomes a factor. For example, a 0 of -2 with multiplicity 3. Well, since the 0 is -2, we would write x minus -2, which is x plus 2. And since the multiplicity is 3, we would put a power of 3 on it, and it would look like that. X plus 2 to the third power. But with the 0 of 3 with multiplicity 1, if we put 3 in here, it would say x minus 3, and multiplicity of 1 means that the power on it is 1. And so our function has to have these factors. And since we want the lowest degree, there are no other variable factors, which means our function has to contain x plus 2 to the third power and x minus 3. No other variable factors because we don't want a higher degree than necessary. But what about f of 0 equals 120? Well, if we take our current function and put in 0, we're going to get 0 plus 2 cubed times 0 minus 3. But that's equal to -24 and not 120. We need it to come out 120, not -24. So how are we going to do that? The answer is to throw in another factor. Now you might be saying, you just said don't put in another factor. And what I said was don't put in another variable factor. Well, what other factors could we put in? Well, something that's not a variable. In other words, a constant. We can include an unknown constant factor to address f of 0 equals 120. In other words, we can take our function and we can put in some number that we don't know. That's c. I want to make that a little bit wider. We can put in some other number that we don't know. This c. Oh, that's kind of a big chunky arrow, but that's okay. And that c can be anything we want, because if we put any stray number out there, it's not going to change the fact that this produces a 0 of -2 with multiplicity 3, nor will it change the fact that this factor produces a 0 of 3 with multiplicity 1. So all we got to do is figure out what number we're going to put in there. Well, let's take a look at it. Do a reveal here. If we put 0 into this function with the extra c in front, the c will stay the same because we're putting in 0 for the x. And then we'll get x plus 0 plus 2 cubed times 0 minus 3. Now, we've already figured out this part. We figured out this part on the previous page. That was equal to -24. But the problem is we've got that c lurking around. So when we simplify all the numerical parts, we get -24, but it's still attached to a c. But what number do we want to get out of here? What we want to get out of here is 120. And so the only way it's going to be 120 is if we solve -24c is equal to 120, and that'll tell us what the missing constant factor is. All we have to do is divide both sides by -24, and we get c equals -5. So what does this mean? This means that -5 is the number that should go right there. So our function is f of x equals -5 times x plus 2 cubed times x minus 3. And if you notice, I've got a note there that the homework wants this answer multiplied out. I figured this out on the first take of this video when I was in this problem, and I started typing -5 and tried to type in open parentheses, and it would not let me. I can type away at it all I want. It won't. 9's all day long, but no open parentheses. So the only way I can type in this answer is without parentheses, and the only way I can get rid of the parentheses is to multiply all this out. Now, this may seem like a pretty tall order, and I guess in a sense it is, but it's not something that's unmanageable. You just have to stay focused. All right, so let's write it all out first. F of x, let's take this down a notch. F of x equals -5 times x plus 2 cubed, so we'll write it out 3 times. And then we also had x minus 3. So we've got 5 things we need to multiply out: the -5, all the x plus 2's, and the x minus 3. But the problem with multiplying is that we can only do 2 factors at once. So we need to pick a pair of factors, multiply them, and then see what we can multiply next. There's a lot of places to start here. Some people might want to start with distributing the -5. Truth is, I'd rather save that for last. Why? Because I would rather grab these 2 guys and FOIL them. Grab these 2 guys and FOIL them. And I can do both of those moves simultaneously. Let's see what we get. -5. All right, in the first FOIL problem, the first part is x times x, which is x squared. Let me erase where it says FOIL here. The outside and the inside will give us like terms. The outside is positive 2x, and the inside is positive 2x. Positive 2x and positive 2x is positive 4x. And then the last part of the FOIL is positive 2 times positive 2, which is positive 4. And we'll do the same thing for the second one. Let's erase where it says FOIL, and we'll change colors. We'll make it blue. All right. The first part of FOIL here is x times x, which of course is x squared still. The outer and inner products will be like terms. The outer is -3x, the inner is positive 2x. -3x and positive 2x is -1x, or just -x. And then the last part of FOIL is positive 2 times -3, which is -6. All right, we've gone down from 5 factors down to 3, but unfortunately 2 of them are big and chunky. 2 of them are trinomials. It's not the end of the world, though, because we can't call it FOIL. FOIL is a gimmick for a binomial times a binomial, but we can do a whole heap of distributing. Just keep in mind that when you multiply polynomials, you're doing the distributive property repeatedly. The best strategy, in my opinion, is to pick one term in the first polynomial and then distribute it to all of the terms in the second. So we're going to distribute x squared to all 3 of these, and I'll write down the results in green. X squared times x squared is x to the 4th. And let me put a box down here so I can move it. All right, x squared times x squared is x to the 4th. X squared times -x is -x cubed. And then x squared times -6 is -6x squared. All right, there are the results of distributing the first term from the first factor across the second factor. Now let's do it again, but this time we'll do it in orange. And we're going to distribute the second factor of the second term of the first factor. And I'll also bring back the parentheses I got rid of. And we're going to distribute that to all 3 terms of the second factor. Let's bring up a box for focus. All right, starting with positive 4x times x squared is positive 4x cubed. And then to the next term in the second factor, Positive 4x times negative x. Well, positive times negative is negative. 4 times 1 is 4. X times x is x squared. And then moving to the third term, moving to the third term in the second factor and multiplying. Positive 4x times negative 6. Positive times negative is negative. 4 times 6 is 24. And then we have the single x. All right, and let's do the same thing, except now with the third term of the first factor, which we will do in this color of blue. Now we're going to distribute this last term of the first factor to all the terms of the second factor. This is really just keeping up with everything. The math, the individual math is pretty easy. All right, so starting with positive 4x times x squared is positive 4x squared. And then move to the next term in the second factor. Positive 4 times negative x is negative 4x. And then finally to the last term in the third factor, positive 4 times negative 6 is negative 24. We're almost there, because now we have to do is gather all the like terms in the giant parentheses on the bottom, then distribute the negative 5. All right, let's start by tracking down all of the x to the fourth powers. Here's an x to the fourth. It's the only one. So I have x to the fourth power. Now let's track down the x cubes. And what I like to do is find the terms I'm looking for, combine them, and then cross them out. So I'm just going to draw a light x through, we'll do it in black. I'm going to cross out that because I'm done gathering those. Now let's move to the next highest power, which is x to the third. Here's an x to the third, negative x cubed, and there's another one here. And I believe that's all of them. Yes. Negative 1x to the third and positive 4x to the third is positive 3x to the third. I'm done with those, so I will cross them out. And again, this is just a bookkeeping issue. I'm done with the x to the third terms. And now let's find the x to the second terms. There should be 3 of them. Here's a negative 6x squared, a negative 4x squared, and a positive 4x squared. Well, in this case, the negative 4x squared and the positive 4x squared cancel, and that just leaves me with negative 6x squared. And I am done with the x squared terms, so we'll cross them out. Done with you, done with you, done with you. Now let's find the x to the first terms. There's 2 of them. There's a minus 24x and a minus 4x. And when I combine those, I get a minus 28x. Done with you, done with you. You don't have to cross out and highlight and all that. That's for instructional purposes, but it does help when you have a massive problem like this. And then the last thing I look for are my constant terms, but the only constant term is negative 24. And so I am done with that term. So just stay the course, stay focused, and you should be good. Now we're not quite done because we still got to get rid of the last parentheses, but now I'm going to distribute the 5. I didn't distribute the 5 at the beginning because it makes numbers larger early on, and then I have to do more math with the larger numbers. I'd rather say the negative 5 for the end to make the numbers larger at the very last moment. Okay, just distribute the negative 5. Negative 5 times x to the fourth is negative 5x to the fourth. I'm going to move a highlight around so you can see which term I'm on. So we're doing negative 5 times a term over here. All right, we just did that one. Negative 5 times positive 3x squared. Negative times positive is negative. 5 times 3 is 15. And then we have x cubed. I think I said x squared. Moving to the next term. Negative 5 times negative 6x squared. Negative times negative is positive. 5 times 6 is 30. And then we just have the x squared. Move to the next term. Repeat. Negative 5 times negative 28x. Negative times negative is positive. 5 times 28 is 140. And then we have the x. And then lastly, negative 5 times negative 24. Negative times negative is positive. 5 times 24 is 120. Not a coincidence, because think about the initial condition. And now we finally have what we think is the correct answer. F of x equals negative 5x to the fourth minus 15x cubed plus 30x squared plus 140x plus 120. I'll take a picture of that because I'm about to switch over to the homework to type that answer in. And when I share screen with the homework, I can no longer see the whiteboard. So over to here. Hello, there we go. All right, cross our fingers. I'm pretty sure everything went correctly, but I've had that feeling before and with drastic results. Negative 5x to the fourth. Let me type that again. Negative 5x exponent 4 minus 15. Oh, look, I'm typing too much in the exponent. When you need to leave an exponent, press the right arrow key to get out of the exponent. You should know that by now. Minus 15x to the third plus 30x to the second plus 140x plus 120. First time. All right, we're going to do one more video because some of the problems are a little bit trickier, like number 7, where you have a fraction and an imaginary number, or number 9, where you have 2 complex numbers. Geez, I'm not sure which one I want to do. I mean, we're already on video. I don't even know what video we're on right now. Do you? It says it at the beginning. It's been a long morning. We're currently on video 6. I really don't want to make it have 8 videos, but maybe it'll be good to have 8, and then I'll just do one without all the commentary.